so Landon, you were saying you had some questions. So let's start there so that we've got them. All right. And Landon, what problem number is it? Do you remember? Okay. And you said it was 3e to the x? Okay. That's all right. So in the homework assignment, it's problem number 8. And it was 3e to the x. Okay. All right. And, well, e is a number. Remember, e is a base. It's not a variable. E is a little bit less than 3. So e is, so we're just going to treat it like a number. So this is essentially 3 e to the x equals 7. We want to get this base to the exponent alone on one side, and we want the other side to also be just one term. Yep. And then what neutralizes an e? Like, what's the inverse operation for e? Nope. Nope. It's not e or 1 over e. We want to take the natural log of e to the x and the natural log of 7/3. E to the x equals y, and the natural log of y is e to the x, are inverse operations. If you want to undo an e, you have to take the natural log. What are you going to do with this x? And this is division. So what can we do using your laws of logarithms? What can you do with the division? And what do you know about the natural log of e? Yep, that is 1. So we just have x is equal to ln 7 minus ln 3. And then all we got to do is plug that in to get the number for x. This is our exact. Oops. Whoops. I got to watch my parentheses. ln 7 minus ln 3. 0.847 if we're going to 3 places. Why? Oh, are you having to mute yourself because you're in class, Landon? Okay. All right, any questions? Austin, you good? Okay. Oh. No worries, Landon. I'm glad there's a little tension release there. Okay. All right. Was there another one you wanted me to go through, Landon? I did see you, Kristen. Thank you for letting me know. Yeah, Landon had the same problem. No worries. I'm glad you made it in. Oh, gosh. All right. Landon, did you have another question? Well, there were two problems I didn't get to. So I was going to do those, and then there's a whole other half of the assignment, which I think is Thursday night stuff to do. Okay. Well, let me look at doing the two that I wanted that I didn't get to yesterday. And so the two that I didn't get to were exponential equations, which were quadratic types. And so this one looks like e to the 2x minus e to the x minus 6 is equal to 0. And the idea here is that you use a substitution and you let w equal your e to the x. If we make a w substitution, then what we have here is w squared minus w minus 6 is equal to 0. Then this guy factors. And we have that w has to equal 3 or w has to equal, negative 2. Once I know what the w's are, then I can substitute back. So e to the x has to equal 3. And ln of e to the x is the ln of 3. The x comes out front. Ln e, as we said earlier, is just 1. And x is the ln of 3. Or it could be that e to the x is a negative 2. So the ln of e to the x is an ln of negative 2. You can't take the natural log of a negative number, so that's a domain error. And our x value is just the natural log of 3. You can't take the natural log of a negative number, right? Natural log of a, given that a is positive or greater than 0, and a is not equal to 1. So we can't do that part. So we're just left with the ln of 3. Questions on that one? Okay, Kristen, you still good? Okay. What do we do with one like this? Well, I don't have any squareds here, but it's also not in order. This should be written as e to the x minus 8 plus 15 e to the negative x. Your exponents should be in a decreasing order, which means first power, no power, negative power should be the order. I can tell you that what I would do here is to multiply this entire equation by an e to the x. Because when I do that, e to the x times e to the x would give me e to the 2x. Minus 8 e to the x plus 15 e to the negative x times e to the x would be e to the 0, which is just a 1. And then e to the x times 0 is still 0. And now it's a power rule. E to the negative x times e to the x is e to the negative x plus x. This is e to the 0. And what is any number to the 0? Because any number to the 0 power is 1. It's not that it's nothing. It's that the power rules work to our advantage to cancel or eliminate the e to the negative x. Now I have a quadratic, e to the 2x minus 8 e to the x plus 15. And I can do the same. Let w equal e to the x. W squared minus 8w plus 15 is equal to 0. And are there any two numbers that that multiply to give you a positive 15, but add to give you a negative 8? So this is a w minus 5, w minus 3. So w could be a 5, or w could be a 3. Since w is e to the x, e to the x could be 5, which means x would be the natural log of 5, or, oh shoot, e to the x is 3. Oh my goodness, sorry, it was unplugged. There we go. And x would be the natural log of 3. The second type I didn't get to yesterday was, again, exponential equations. But this time, with exponential functions. All right, so for these guys, we're attempting to solve ones that have an exponential function in them, so 10 to the x squared 10 to the x minus x 10 to the x equals 2 times a 10 to the x. All right, so what I'm going to do here is I'm going to still move it so it's equal to 0. Now, do you see how 10 to the x is used over and over in this guy?
Yeah.
So I'm going to take that 10 to the x and I'm going to pull it out front. Now that I've got it pulled out front, can you factor this? X squared minus x minus 2 will factor into x. Okay. Now what do you think? Well, this is a base 10, so I'm going to take a log, a common log. And since I'm multiplying them all, I can use addition. This x comes out front, and then I have log base 10 of 10. So that's just going to be an x. So get x plus, I don't know if I wanted to do that. No, nope, you can't pull that. You can only do that subtraction if it's division, and if it's 2, this has to be 2 separate logs in order to put it as x over 2. It would have to be log of x minus log of 2 in order to make it log x over 2. I might not have wanted to do that. What might I wanted to do instead? I don't know if I wanted to do that. Right? Because that's log and log. Huh. I mean, I can't distribute the log. Like I can't make it log of x minus log of 2. I can't do that. It's a nice shot, but that's not a possibility. Since this is log of x minus 2, log of x plus 1, I could go back and multiply those again. But I don't know. Okay, I'm going to try something. I'm a little stuck at the moment. It happens. But this is where I try things. Okay, so so I've got x. I'm going to do plus log of x minus 2x plus 1. So I'm going to put them back together. Oops, can't see that, can you? Right, so I'm going to put them back together. And then I'm going to move this over, all of this over to the other side. I'm a little stuck, because now if I do 10 to the x, that's going to be x minus 2x plus 1. That doesn't help me. That's helpful, but that's not going to help. Oh, for crying out loud, Amy. Okay. I found where I made my mistake. All right, right here. Right here. You see that? All the way up here at the top. Third step in. I'm going to divide both sides by 10 to the x. I can do that, right? 10 to the x is just some number. And so I can divide both sides by whatever that factor is. Zero divided by whatever that factor is still going to give me 0. So I'd have an x minus 2, x plus 1 is equal to 0. So x would be 2, or x could be a negative 1. Bless us, everyone. Here I am trying to make it incredibly hard, and it just turned out to be rather slick. Now, do you have questions about why I messed that up? Do you see how I got stuck in this has got to be a log of something? So I got stuck in this mentality of I need a log or a base 10. And really, it just, because it's a factor and it's set equal to 0, it goes away. Right? All right. Beautiful. All right, so that was it for the exponential equations. Then we're going to solve logarithmic equations. Okay. So a logarithmic equation is one it is an equation that contains a log. Or a variable in the log. Okay, remember, log base a of x is equal to a log base a of y, then it must be true that x is equal to y. So what does that look like? This should be 2 times. Log of x is equal to log of 2 plus the log of 3x minus 4. All right, so what we're going to do is we're going to use the combinations that we practiced last week when we took our logs and tried to combine them or condense them. And we're going to set it up so that we have one log on the left side and one log on the right side. So as close to that as we can get. Meaning, if I have 2 times log of x, what can I do with that 2 so it's just log of something? Yep. This 2 can go up as an exponent. So using the rules of logs to condense them, 2 times the log of x is the log of x squared. Now on the left, or on the right side here, I have log of 2 plus log of 3x minus 4. What can I do with these 2 logs? When I'm adding 2 logs of the same base, that is the same as the log of 2 times 3x minus 4. Now, since this is the log of x squared, log base 10 of x squared, and this is log base 10 of 2 times 3x minus 4. They're both log of the same base, so it has to be true that x squared is equal to 2 times 3x minus 4. This is just what we set up here. If we have a log base a of x and it's equal to a log same base but some other expression y, then x and y have to be the same. So x squared is 2 times 3x minus 4. And now I have a quadratic. X squared is 6x minus 8, or x squared minus 6x plus 8 has to be 0. So what about our values of x? So x could be a 4 or a 2. I will now check to make sure that 4 works in the domain of each one of these original logs. Can I take the log of 4? Yes. Can I take the log of 2? Yes. Can I take the log of 12? Yes. Wait, 12 minus 4 is 8. So, yep. And can I take the log of 6 minus 4 is 2? Yep. So both of these will work, as they will work in the domain of each one of those logs. Questions there? Okay. Whoops. Okay, second example. Oh, I got time lines. All right. I've got the log of 3x plus 5 is equal to 2. Now, this one is new to us because I don't have a log on both sides. I have a log on the left side, but not on the right side. There's a couple of different things here. We can use our definition of a logarithm. By the way, what base is this? Log base. So there's a 10 here, even though we don't write it. If I use my definition, I know 10 to the second power has to equal 3x plus 5. Well, do I know what 10 to the second power is? Ten squared is 100. 3x plus 5. Does this seem too easy? Yes and no. But it works. And if I put 95 over 3 in, 3 times that is 95, plus 5 is 100. Log base 10 of 100 is indeed 2. And so it checks. Did you check that out? Did it work for you? Okay. Good. think I might run out of room for this one, but that's all right. I can get it done. All right, let's try log base 9 of x minus 5 plus log base 9 of x plus 3 is equal to 1. These two are being added. They have the same base. So using my law of logs, I can do log base 9 of x minus 5, x plus 1 is equal to 1. Thank you. I did mean x plus 3 is equal to 1. Then if I use my definition, it's going to be 9 to the first power has to equal the result here, x minus 5, x plus 3. So 9 is x squared minus 2x plus 15, or minus 15. If I subtract 9 from both sides, I will have 0 is x squared minus 2x minus 24. Can you factor that one? X squared minus 2x minus 24? So x could be 6 or x could be a negative 4. Oh. So I do want to check if I put in a 6 to the original equation, I can take, remember the original, it was on the other page, log base 9 of x minus 5 plus log base 9 of x plus 3 is equal to 1. So if I put my 6 in there, that's a positive 1, and I can take the log of that. If I put my 6 in there, that's a positive 9, and I can take the log of that. But if I put in a negative 4, can I take the log of a negative 9? So we're going to eliminate this x equal negative 4 because it'll give us a domain error in the original problem. In other words, I can solve for that x value could be a solution, but it doesn't work in our domain. Because remember, logarithms can only be taken for positive numbers. Yeah, so x equals 6 would be our final answer. Right? Other questions? Okay. All right. I just want to move into an application at this point. But I did want to say that there are some problems at the end of the second part of the homework, and maybe at the first part, but for sure at the second part, the one that's due Thursday night, that tell you to solve it graphically. You will need to plug it into Desmos and get approximations on some of them. All right? Look for them to say solve it graphically. And it does say that, then there's zero expectation for you to solve it algebraically. Okay? All right. All right, let's take a look at some applications. The first one is compounded interest. We've done some of these compound interest problems before, and I had said we wouldn't be able to find some pieces until we solved logarithms, which is what we're doing here. So we've got a woman investing $6,500 in an account that pays 6% interest, compounded continuously. What is the amount after 2 years? And part B says how long will it take to reach $9,000? Okay, so for compounded interest continuously, the formula is that the amount, is equal to the principal times e to the RT, or PERT, where R is the interest rate, P is the principal amount, and T is the time in use. So the amount after 2 years, we're finding the A. The principal was $65,000. The E is just our numerical base. Our rate is 0.06, and our time is 2 years. This is just the plug and chug portion. So we're going to do, oh, it froze, didn't it? Okay, fixing. There we go. So we're going to do 65,000 times E to the 0.06 times 2. And simply plugging that into a calculator, we get $7,328.73. That's just going to be a plug and chug. Part B asks us how long will it take to reach 9,000. This time, our A is going to be that 9,000. Our T is unknown. So we will have 9,000, 6,500, E to the 0.06 T. Now, to solve this, we have to do what we were doing with our exponential functions. We have to get our exponential portion alone on one side, meaning we're going to divide both sides by the 6,500. By the way, this reduces to 18 over 13. Then I'm going to take the natural log. Because this is an e, I want to take the natural log of both sides. Then I'm going to use my laws of logarithms to expand this. And bring the 0.06t out front. Times my ln e. And just like before, ln e is just a way of writing 1. And at this point, to get the t alone, I'm dividing by 0.06. To get a final answer, I'm going to do ln 18 minus ln 13. That's my numerator. And I'm just going to divide that by 0.06 to get 5.424. Right? And there are a couple more different ones, but our next 4.6 is all word problems too. So we can kind of meld those in together. But, right? Any other questions for me today? Okay, Landon. You should be able, at this point, you have seen all of A,